So I'm here to talk to you about how to ruin your product by using Agile as an excuse not to plan. And yeah, that's a little bit sarcastic, and mostly I'm going to be giving you lessons about how to avoid this fate. So by way of introduction, I missed a slide. Weird. Sorry. So the agenda: introduction, a very brief review of Agile for those of you who aren't necessarily familiar with it and have worked with it day in and day out. How to fail. It's pretty easy, but I'll give you some key learnings there. Think before you code, how to balance tactics and strategy. Code is not your only deliverable, and then I'll sum things up at the end. So who am I? I'm pretty much what Mr. KRS Murthy said. I'm a veteran of Microsoft and Amazon. I've got more than 2 decades of experience in online services and SRE and the TPM. I have been a victim of Agile gone wrong on more occasions than I really feel comfortable counting. And I really consider myself to be a student of failure and how to learn from it. I got a brief war story to start with, which is the control plane that didn't. Working for Amazon, I worked on Sable, which is, depending on who you talk to and what day it is, the largest NoSQL instance in the world. And there was some automation which was responsible for taking bad servers out of service and replacing them with good ones. And the scripts worked fine. They eventually built it into a control plane, but they didn't really design the control plane to do all the things that it really needed to do. So for instance, in your 10,000 plus server cluster, you could replace 1 server at a time. So this is a very good example of how not to design and how to concentrate on your near-term deliverables as opposed to your long-term vision. So a very brief review of Agile. So what's the fuss about Agile anyway? I can tell you what it isn't. It's not a framework. It's not a methodology. It's not a process, it's not a set of rules, and it is certainly not descriptive. So that leads you to the obvious question: if that's what Agile isn't, then what is Agile? And Agile is really just a loose set of principles which can help guide your software development. And the principles are usually described as working software in over comprehensive documentation. The built software, it stands in as your spec rather than trying to document every little thing. Most people aren't going to read your documentation to that degree anyway, and the documentation tends to fall out of sync with your built software anyway. So the built software really is the spec. Individuals and interactions over processes and tools. It's self-defined teams with frequent face-to-face communication, where face-to-face also includes video collaboration. It's very typical to have a sync meeting once a day or a stand-up meeting where everyone has their personal interactions. You can describe your challenges, blocking issues, etc. Customer collaboration over contract negotiation. And this is really an acknowledgement that the customer needs can and will change. And in order to build good software and good services, you have to flexibly adjust to that reality. Customers don't always know what they want, and sometimes once you give it to them, it's not what they needed. Want versus need is a very big question. What they want is not necessarily what they need. And ultimately, to get that flexibility, you need to be prepared to respond to change instead of following a very rigid plan. And Agile really wants to deal with iterative processes where you build small chunks of deliverable functionality at a time, and you learn from experience. And as you learn more about the requirements, the difficulties, what your customer really needs, you have to be willing to change course, which is to say, Agile is not waterfall. But I just said responding to change over following a plan. So clearly there's something that's not necessarily consistent here. So how to fail? Just because you have priorities in your principles does not mean that you can safely ignore everything else. Note that the principles are X over Y. It doesn't mean that Y can be completely ignored. It just means that you have a prioritization. So our course for failure 101, no definition of success. Is your product successful? You have to define success, and it needs to be defined based on objective criteria. And in order to look at objective criteria, those criteria must be measurable. Ask yourself, what's going to encourage people to use your product? The features, the reliability, the performance, the security, the privacy, and that list goes on, but those are most of the players. So what's going to discourage people from using your product? The lack of the very same things. So the exact same things which can make people want to use your product, if you do them badly, can be very effective in convincing them not to use your product. So assuming you have a successful product, or you have a product that you've managed to get out the door, what would cause you to stop developing that product? And frequently it's either too costly to deliver, it's too difficult to maintain, or you don't have a sufficiently large user base to support the application as you have in mind. These are all basically, you didn't necessarily define success gracefully. So the next layer of failure is you didn't plan for success. And really, functionality is just one part of a successful product. Your incremental features rarely exist in a vacuum. There's complex interplay between these features, and everything really needs to play nicely in the same sandbox. And you need to have a set of overarching requirements that are absolutely essential to meet your definitions of success. And there's a lot of invisible items that you need to deliver functionality and delight your users. These include, and this list isn't exhaustive, code testing, data integrity, available and security. You have to be available, you have to be reliable, you have to have limited downtime for maintenance, you must have good performance and scalability, you have to have monitoring, incident management, disaster recovery, geo-redundancy potentially, and that list just goes on. So your functionality and what you offer the user is only one portion of the success metrics for a good, highly available online service. Failure 301, we didn't plan for Murphy. Things are going to go wrong. Most notably, there is no such thing as a safe change. Once you acknowledge that there's no such thing as a safe change, you have to build your system so that you can diagnose your failures quickly, and so that you can automate responses to failures and roll back bad code deployments aggressively. Everything needs to accommodate failure. And those failures are going to occur in areas where you have potentially zero control whatsoever. You have partners that you can't control. You have network providers you can't control. You have hardware that you literally can't control. You have data center infrastructure like power and cooling that are going to go down, and maybe you don't own your own data center and that's out of your control. But even if you had control over all of those things, you don't have control over what bad actors are going to try to do to your service. And you have to acknowledge that failures do come in various flavors, in that coming up cold from a completely down service is often not the same as recovering from a partial outage. This is especially relevant for things which are cache heavy. It's especially relevant for times when you can basically bring up your servers, have only part of your pool. Your pool will get plowed under by all of your requests if you don't protect the pool while it's coming up. And you really need to determine your responses to these classes of huge failures before, not during, an outage. And you need to have your runbooks documented. You need to have your incident responses well tested. Basically, a process that you've never tested, you should have zero confidence in. And by testing, I mean testing regularly. So from there, now that we understand how to fail correctly, let's start thinking before we code, because the cheapest place to make your changes is when you're designing something and you haven't written a line of code yet. That is the easiest place to make changes. So for Design 101, let's anticipate failures. Death, taxes, and online services failing are really the only truly reliable things in life. So in order to understand failures, we need to understand and define what is acceptable. Because if you don't know what's acceptable, you don't know what a failure is. Typically, you don't want to design for much greater reliability than you need or much greater performance than you need, because both of those are going to add large costs and frequently limited benefit to your customers. Typically, this is described as how much does that last 9 cost? Each 9 costs somewhere in the neighborhood of 10 times what the previous 9 cost you. So be very careful. Design to your real requirements as far as that goes. You need to design for fast recovery from your failures. In order to design for fast recovery, you need to monitor and measure your system state accurately. You need to automate the responses where possible, because let's face it, automation is faster than pinging any human on a pager, especially at 2 in the morning when they have to roll out of bed, no coffee, and log into your corporate network to try to fix something. And you really want to include your large-scale failures, both yours and your dependencies, in your recovery scenarios. Basically, how do I recover from a network outage? How do I recover from anything, whether I own it or not? Now, you want to consider having degraded modes of operation. Basically, think about the idea. Supporting some user scenarios or users is vastly better than supporting none of them at all. Just because you have a component down, there may be scenarios in your service which will function perfectly well without that component. Let them. Or for example, you may be stuck in a read-only state. Well, you can still do a lot of things for the user that aren't going to involve writes to your database. Let them do it. And you're also going to want to have multi-layered security, because anything is a potential single point of failure depending on how you design it, security included. And really, let's make it harder for bad actors to succeed. Let's not make their job any easier. You can't avoid bad actors being out there. If your service gets popular enough, you're going to attract their attention. Don't make it easy on them. And as much as anticipating failures, you also have to anticipate success. Because the most dangerous time for your online service is when it's been embarrassingly successful. Architect your service to be scalable if you might need it. This may not apply to internal tools and other situations where you have a guaranteed small user pool, but for the lion's share user case, you're probably going to have to be scalable. So keep the hooks in place where that's easy to do. Typically, this is going to mean avoiding monolithic structures. Monolithic structures often can't scale important subsystems independently, and this will force you to overscale the entirety of your service to compensate, and that gets very, very expensive. If you use microservices and similar architectures, that allows your components to scale more efficiently, so that when you're engaging in a scalability exercise, you can scale only the bottlenecks that most needed at any given point in time. You really want to avoid processes that scale linear with people. Just because you've designed your service to be scalable does not mean that your staff can scale in the same way. And you really need to protect your servers from excess or bad traffic, because again, serving up some of your traffic is better than serving up none of it. Your clients can be bad actors, whether they mean it or not. Never mind the actual bad actors who are out there. So one strategy here is to identify your high-value traffic and make sure that you preferentially service that when you're in a constrained resource environment. Design 301, let's anticipate change. The nature of change is that nobody can accurately tell the future. As a result, you want to leave as many possible futures open as is reasonable. There are some futures that are going to be unreasonable and you don't want to support them, and that's fine. But where you have the luxury to leave yourself future flexibility, it usually pays its dividends to you. You want to design for that flexibility and that possibility, because you can't always predict what the user is going to want or need next year. And frequently, in order to make change easier, you want to design with things like APIs and structured interfaces rather than direct calls to resources. because this enables you to change your business logic without having to rewrite and rev every single component that uses it. So having defined interfaces between components is frequently the way to go here. Zero downtime software upgrades. They're a really nice thing to have. Designing your service from the perspective that it must be possible to do it, even if you don't implement all the details, helps future-proof you in case you ever need it. Experience. You want to learn from experience. You want to let it inform you on the future decisions that you make. And change includes changing your direction or your plan in response to new information. It's always a good idea to say, hey, I can be smarter tomorrow than I was yesterday, and I've learned something. And that something tells me there's a better way to do what I'm trying to do. Leave your mind open to those opportunities. And couple loosely. Loosely coupled systems, they're usually easier to change and they're often more resilient. Everything doesn't have to move in absolute lockstep. And it's just a generally good policy that less things will go wrong if you couple systems loosely than if you couple them exquisitely tightly. So all that said, how do I balance tactics and strategy? How do we concentrate on our short-term deliverables and delivering them without sacrificing our long-term vision? And in terms of tactics, one common tactic is delay your non-critical decisions as long as possible. And while I'm saying this somewhat sarcastically, cold feet are sometimes an asset. Committing to a path, discovering that you're wrong, is an expensive way to fail. By delaying your non-critical decisions, you allow yourself to learn more about your problem space. So you don't end up making as many non-critical decisions that can't be easily reversed. And again, you want to leverage one of the main principles of Agile, which is iterate and learn from experience. Another thing which is very important and which is very much underrated is get the right people in the design process. Coders are very good at writing code. Architects are good at designing services. Security experts are good at ensuring that security needs are met. SREs are usually more familiar with where the rubber meets the road and have a different set of expertise because they've run online services and they know exactly how they fail in the real world. And you need someone who represents the voice of the customer, and that's usually the product owner. Now, for any individual service, you may need more than this. You may need someone who's devoted to databases. You may need someone who's devoted to geo-redundancy and has that as the familiarity. But this is the basic idea is, based on your requirements and what your service has to do, make sure you have subject matter experts for each element that your service needs to actually achieve. Tactics 201, try to get the critical architecture elements right the first time. And this may be obvious, but it does bear repeating because your basic architectural decisions are often very expensive or nearly impossible to fix later. Do your research. Understand what the real requirements are of your service, not what you think they are. Don't get hung up around, I need to use X technology. State your requirements in terms of what your service needs to do, and then proceed from there. Don't walk in with preconceptions. Most of the other elements of your service will usually align around the basic architecture, and they're going to be more flexible in terms of what they're willing to tolerate than the fundamental architecture choices that you make. On this list, you really want to make sure that you understand scalability, availability, performance, security, and your data integrity requirements nailed down. Because without at least most of these, you don't actually have a service. So thinking that you understand your actual requirements without addressing these issues is fairly unrealistic. Your initial designs should be initially bound by your non-negotiable requirements. In any design exercise, there's always the, I have no service without these things. There are the things that we really want. There are the things that are nice to have. And there are the things that are like, yeah, that's never going to happen, but it would be cool if it did. And ultimately, what you need to do is you need to adapt your features and your customer scenarios to your architecture. And if you can't do that, if it's obvious that your architecture just won't support your features and your customer scenarios reasonably, now you need to do an architecture redesign until it actually reaches the point where it can. that's pretty much the signal of, yep, this architecture isn't going to work. We need to go back to the drawing board and figure out what we actually need in terms of basic architecture to support what we need to do. Shifting from tactics to strategy. Strategy 101, learn to love two-way doors. What's a two-way door? A two-way door is a decision which can be easily reversed. You can walk through it, you can walk back, and it's relatively not costly. By contrast, a one-way door puts you on a set path with no easy way to reverse or change your course. You're basically committed at that point. And part of understanding and embracing two-way doors is understanding that sometimes you do need to take a step back to take 3 steps forward. And that's fine. You're leveraging one of the strengths of Agile, where you are learning from experience and you've figured out, nope, this was the wrong thing to do. I have a better way. So make your decisions reversible where it's practical. So taking that step back is easy, allowing you to move forward again. And as much as you want to design for flexibility, you also need to be able to plan flexibly. The odds are that you're going to wake up smarter one day than you are today. And it's really important to be able to listen to and be able to implement the ideas of that smarter you. And sometimes that's going to mean scrap and rework. And do that. And don't be embarrassed about it. Getting to the right endpoint is rarely a completely straight path. They are often crooked. That is the nature of the beast. As you understand your problem space more, you're going to have little fits and starts. And that's natural when you're dealing with Agile. It means that you're learning from experience and you're willing to take a step back when you find there's a better way. Which all brings us to how much planning is really enough. And yes, planning is necessary, but this isn't a waterfall. Don't plan every little thing. Let yourself learn from experience what the right decisions are. Accept the fact that you're probably going to change significant elements of your service and what you think you're going to do over time based on what you've learned. Great. This is how it should work. Understand what you need for long-term success and don't compromise on delivering it. This is really the curse of short-term thinking versus long-term thinking. Don't think in terms of, I need to release this feature next month if that feature can't appropriately be supported over the long term, or if it's going to adversely impact the rest of your service. That impacts your long-term success. Don't sacrifice your long-term success. That always has to be in the back of your mind, preferably the front as well, because it's something that you need to avoid forgetting. So really, my planning mantra is plan until you know the general shape of what you want to deliver, how you're going to deliver it, and how you're going to support it during its lifetime. And be prepared for the inevitability that you are probably wrong about everything, and be prepared to adapt to real-world circumstances. It is said that no plan survives first contact with the enemy, and in this case, the enemy is all around you and unavoidable. Just accept that reality. You're going to make mistakes. You're going to learn from them. And you need to be able to adapt rather than trying to assign blame or recriminations. Code is not your only deliverable. Online services are more than just code to be successful. It seems obvious, but you'd be surprised how many people don't quite get it. Note the list: service code and not service code. Notice how there are so many more things which aren't service code necessary to running an online service well. And I'm exaggerating a little bit to say that service code is usually the easy part, but in some senses, it frequently is. You have all of these other things that are necessary for success. And while you have coders whose primary expertise is coding and you can build your service code, it's harder to find subject matter expertise that intersects well with all of the other things that are necessary for successful online services. So how do we get all of those things that aren't your service code into an Agile environment? So how do we integrate our non-code deliverables into our planning and execution? And step one is very simple. Add non-code items to your backlog. Your backlog is the list of things you need to do. Make sure that your non-code items are on the backlog. You also need to understand, what do you need to successfully release your code? Define what is a release blocker. Define what is my required non-code collateral. Frequently, but not always, you're going to want to create a release sprint, because there are some things you only need to do if you're releasing, and that's much of your non-code collateral. Acknowledge that processes often need to change around major releases. A much larger percentage of time is spent doing bug fix work at the end of a major release from newly discovered bugs that aren't in the sprint backlog. You have to accommodate the fact that you're going to find a lot of bugs as you get to the end of your release cycle. Accommodate that. Understand that. It means you need to allocate your time a little bit differently. For one thing, ignore non-blocking code items from the backlog and concentrate on your bug fixes and your necessary non-code deliverables. I cannot overemphasize the import of testing. It includes game days. It includes breaking non-production to ensure that your runbooks and your monitoring and your incident responses are all in line and solid. I'm even a big proponent of breaking production when you can get away with it, because there is no better way to test your redundancy than to artificially induce failures. You also want to be able to test during deployments so that you know what before, after, and during are supposed to look like. There's nothing as embarrassing as discovering that either your roll forward is going poorly and you haven't figured out because you didn't know what you were looking for, or your release is completely tanked because what happened afterward didn't match what you expected or what should have happened. And really, this is your opportunity to train your operational staff and vet your documentation and your runbooks and your incident responses. So I've talked an awful lot, but if you remember nothing else, remember the summary slide. Summary slide's your friend. Even with the principles of Agile, you're going to need to do some planning to ensure the long-term success. And long-term success really is the rubric. You have to balance between, well, if I don't survive next month, I can't care about next year. But if you don't care at all about next year is going to arrive, and then you're just going to have delayed the inevitable. Try to avoid your architectural defects by planning effectively, because they can and often are difficult, expensive, or impossible to fix. Know and agree upon what the real requirements of your service are, and don't deviate from them. Understand what sorts of decisions can wait and what sorts of decisions cannot. And this is basically embrace cold feet when cold feet are right. Use your two-way doors when you can. They're not always an option, but trying to figure out how to turn a one-way door into a two-way door is often a very, very interesting intellectual exercise, and will often lead you to a better set of decisions. Ultimately, the customer does not care if it's your fault or not. You're still going to get the blame. So design accordingly. It doesn't matter whether it's your fault. If the customer interfaces with you and you fail, it doesn't matter if it's your fault. You are still to blame. And lastly, learn and adapt. It's not so much an idea of one must rigidly adopt Agile principles. That kind of goes against the very idea of Agile in the first place, which is learn from experience and do what works. So don't be afraid to adapt things to your actual needs. If you need to bend a principle here or there, understand why and understand what you're gaining versus what you're giving up. But don't be hidebound. Don't be inflexible. That goes against the very spirit of Agile entirely.